Okay, so we are on section 2.5, and it is infinite sets. Okay. So, we have a definition to start with, and we've talked about infinite sets before, but this is just kind of a little recap. A set is infinite if it can be placed into a one-to-one correspondence with a proper subset of itself. Okay, and so that's the first thing that we kind of need to remember is what does it mean to be a proper subset? Remember we talked about subsets and we talked about proper subsets. And a proper subset just means you chop off the set itself. Remember we had two rules with subsets. Like you could list all the subsets plus the set itself is always a subset and the empty set was always a subset. And if it's proper subsets that they want, then you take off itself. Remember that was the n minus 1. Okay? So, we're talking about infinite sets, and the way to determine if a set is an infinite set is we go, okay, can we make a proper subset out of it where then I can match every element of the big set to an element with the subset, okay? So let's look at example 1. And it'll get a lot clearer once we do a couple of examples. We want to show that the set -1, -2, -3, -4, -5, and we have our ellipsis, closed brackets, is an infinite set. Okay? So, it says an infinite set happens if it can be placed into a one-to-one correspondence with a proper subset of itself. Okay, so let's look at what they've given us. It looks like they've started listing all the negative integers starting with -1. Guys, an integer are the negative numbers 0, 1, 2, 3, 4, and the counting numbers. You take the counting numbers, you take zeros, and then all their negative counterparts, and those form all the integers, okay? So it looks like we started with -1 and we're counting backwards on the number line. We go -1, -2, -3, -4, and they're listing them all. Okay? So what I need to do is I need to take that set and I need to find a subset, not itself, but another subset in there, and I got to show that everybody matches to one. The way we typically do that in this section, anyways, for your purposes, is we decide that we're going to multiply that original set by something, okay? So, the original set is -1, -2, -3, -4, -5. Okay, so let's make a subset. A proper subset. So pick a number. Pick a positive number between, y'all pick a positive number between 1 and 5.
3.
Okay, let's pick 3. So if I pick 3 and I decide that my rule is 3n, and all that means is I'm going to multiply everything in that original set, each one of those elements, by 3. Okay? That's gonna make my subset. Okay, so I'm gonna say proper subset. Okay, so -1 times 3, what does that give me?
-3.
Good. -2 times 3, what does that give me?
Wait, which?
-2 times 3.
-6.
Yep. And then -3 times 3.
-9.
Yep. Then -12. Then -15, right? And it keeps going. Okay. So my question for you is -3, -6, -9, -12, -15, is that a subset of -1, -2, -3, -4, -5 as we keep counting? Yeah, it is, because I've got -3 right there. So in my subset that I made, where I multiply times 3, -3, it comes out of that top set, right? -6, I'm eventually gonna list that, aren't I? I'll eventually list -9, -12, -15. So that is a subset. This set also forms a one-to-one correspondence because what you've done, you forced it to. You said, I'm going to take every element in that top set and I'm going to multiply it times 3. So when I do that, -1 only goes to -3. Yes, ma'am?
So I think I missed it, but whenever you're multiplying everything in the set, are you always multiplying it by like the inverse of it? Like if it was positive numbers, then would you multiply it by the negative?
You always multiply it times a positive. Even if it's positives, pick a positive.
Okay.
Because it makes life a little difficult if you start picking the negative numbers.
Yeah.
You could, but this one you can't, because the negative times a negative would make a positive, and there's no positives listed there.
Okay.
So just in general, pick a positive number.
Okay.
Yeah. -4 will automatically pair with -12, right? -5 will only pair with -15. There is a one-to-one correspondence. Because for each element in the big set, I can match it to one element in the second set, in the subset, right? That -1, since I'm multiplying times 3, that -1 will only go with -3. -1's not going to go anywhere else, because we said multiply times 3. Okay? -2 is only going to go to -6, because I'm multiplying it times 3. -2 doesn't correspond with anybody else. So pretty much, could you make a rule where you paired them together, and somebody in that top set's not going to go 2 places? Okay? You only need to go 1 place. If you can show that, if you can write a rule that happens, and you picked a subset, which y'all can easily pick a subset, because you picked the subset when you wrote the rule, then that means that top set in question is an infinite set. So we say -1, -2, -3, -4, -5 is an infinite set. Now, when they have you do these on the homework, they lead you through it, okay? So it's not as broad, general, wide open as this problem. And we're going to do one from the homework next, actually, and it has 3 parts on it, okay? And I'll show you how it leads you through there. So in example 2.
Is the test going to have stuff like that? You know how like the part you were just talking about? That's kind of
Yeah.
homework instead of...
Yeah, it will. I'll rewrite it. It won't have since it's on paper, you can't have the interactive drop downs, but I'll rewrite the questions. I'll retype them up so that it kind of has the same parts. So like on question 2, say if it's a 3-part question, it's not an all or nothing. You get some point, like if you get part of it right, you're getting some points.
Is that something all 2.4 was? There's just parts.
Yeah, it just had parts in it because and there will be questions like that where it goes, okay, what's the intersection of the scholarships and grants, but not loans. I think that was one of the questions, and I think that's one of the questions on the review. So, example 2 says, show that one of the following sets is an infinite set by assigning an appropriate correspondence with the other. And this question came right out of your homework, okay? And it has 3 parts. So they call it part 1. We're going to call it part A. Oh, I didn't finish the question. I'm sorry. We have set A equals 2, 3, 4, 5, 6, ellipsis, and B equals 6, 9, 12, 15, 18, and then ellipsis. Okay? And part A says the set blank, they have a box, is a proper subset of the set blank. Okay? So pretty much what they're asking you in this first one is you've got to figure out who's the big set and then who's the subset. Now remember, the subset comes from the big set. Like you got to be able to pick all those numbers out of the big set to be a subset. Okay, so do you think A is a subset of B, or do you think B is a subset of A?
A is subset of B.
Okay, if A is a subset of B, that means I can pull a 2 out of B, I can pull a 3 out of B, or 2, 3, 4, and 5 in B? No. B, because you got to look at it like, okay, are all the things in A also in B to be a subset? Or is it the other way around? Other way. So what we're saying is if B is a subset of A, that means 6. There will eventually be a 6 in A, right? Yeah. 9. Will there eventually be a 9 in A? If I kept writing. Could I pull a 12 out of A? Yes. Every element in the subset has to be able to be plucked out of the big set. Okay? To be a subset, you're just a part of the big picture. Okay? So the set B is a proper subset of the set A. Okay? So what that means is we have A right here. It's the big set. 2, 3, 4, 5, 6. And then we have the proper subset B, 6, 9, 12, 15, 18. You've shown you got two rules pretty much for it being an infinite set. One, can you get yourself a proper subset out of that set? Yeah, we did that. B is a proper subset out of A. Okay? The next one is, can you find a one-to-one correspondence? Okay? That just means, can you write a rule where 2 will always go with 6. 3 will always only go with 9. 4 will only go with 12. Okay? So that's what we're trying to do next. It says, define a one-to-one correspondence between A and B. Assign each element, and then I'll let you answer, okay? Assign each element in the set A to the element blank in set B. Okay, they're just looking for the rule, and they're saying act like in A, those are n's. What do you do to each n, each one of the numbers to get B? What do you think?
Times 3.
Multiply it times 3. So this is 3n. They're saying call the numbers in A n so that you can write a rule, okay? Usually you're accustomed to calling them x, right? You're saying like 3x, 4x, 5x, that kind of thing. They're saying call them n because we deal with sets. So when we use set builder notation, we do use x. So they're going, how are we getting from 2 to 6? How are we getting from 3 to 9, 4 to 12, 5 to 15, 6 to 18? And you're right, we're multiplying times 3. Times 3, times 3, times 3, right? And that pairs 2 to 6, 3 to 9, 4 to 12, 5 to 15, 6 to 18, okay? And you write that rule as 3n. And the last part then says the set B is a proper subset of the set A, and the 2 are in a one-to-one correspondence so blank is blank set. Okay? So we pick A or B here. And then you pick infinite or finite. Okay? So it says the set B is a proper subset of the set A. And the 2 are in a one-to-one correspondence. Well, aren't those my 2 rules for being what? Infinite, good. So we know this is infinite set. Now, who is the infinite set? A, because B is the subset, right? So A is, that should be an infinite. An infinite set. Okay, not bad. All right, let's look at example 3. Now, most of your homework is like this, like the next 3, 4, 5, 6, 7, 5 examples. There's 7 examples total today, okay? Example 3 says find a general term for the set 2, 8, 14, 20, and 26. And then we have our ellipses. Okay? Now, they didn't give you, in the next couple of examples, they'll give you it's counting by 1, 2, 3, 4, 5, 6. It's counting by ones, okay? They didn't on this one. They just want you to find the general term here, and I'm going to show you how to do that. So you start off with, we're going to make a T-chart, okay? Y'all remember the T-charts, but we're going to use N this time. We use N this time, and N stands for the original set up there, which there's not one up there, but here's how we do it. Who's in the first spot? 2, okay. Who's in the second spot? 8. Who's in the third spot? 4th spot. And then 5th spot. Very good, okay. Now, just like you used to when you were in algebra, you did this when you had to calculate slope from a table. Some of you shudder when I say that. And then you also did this when you were doing sequences. And you didn't do sequences in Algebra 1 until the very end of Algebra 1, right before you took your STAR test, because there were only like 3 questions on there. Okay, you did it somewhere around the time before you talked about an exponential and you looked at that Nike check mark looking graph, okay? But what we do, we proceed kind of the same way. We look and we go, okay, how did I get from 2 to 8? If I'm just using addition and subtraction, how can I get from 2 to 8? Plus 6, good. It's a positive 6, good. How do I get from 8 to 14? 6. 14 to 20? 6. And 20 to 26?
6.
Okay. Some of you remember doing that. And you would take that, and then on the left-hand side, you would find the differences, and you put the change in Y or change in X, and you mix it. Okay? We don't have to go that far this time. What you have to make sure of is that these are all the same. Okay? Because this rule's not going to work if those aren't the same. So we go over here, and we make another table. And our N stays the same, 1, 2, 3, 4, 5. And we're going to take that 6, that number, that difference that you find, and that's what we're going to multiply by. Okay, so make yourself a little note. Multiply N by this number. If you get the same number all the way down, that 6, we're going to multiply by that number. Okay? So this is going to be 6N. All right. Well, let's see what that makes me. 1 times 6 is? Good. 6 times 2 is? 6 times 3 is? 6 times 4 is? And 6 times 5 is? Okay. Now we're going to leave a blank column. And then we're going to draw one more column over here. And we'll say this is the final. Our final answer that we wanted was 2, 8, 14, 20, and 26. Right? Well, did we get that when we multiplied by 6? No, we got 6, 12, 18, 24, and 30. Well, let's ask ourselves, addition, subtraction wise, how can I get from 6 to 2? Minus 4. So we're going to say 6 minus 4. Yeah, that equals 2. But now it has to work on everybody. Okay? It has to work on all the numbers. So I'm going to say 12 minus 4. Does that give me 8? Yep. Oh, looky there. We got 2 of them. 18 minus 4. Does that give me 14? Yep. How about 24 minus 4? Does that give me 20? Yep. And does 30 minus 4 give me 26? Yep. So what you've done is you said 6N minus 4. Right? That's your answer, guys. That's your rule. Find a general term for the set 2, 8, 14, 20, 26. It is 6n minus 4. There's your answer. We will do more. If you set that table up like that every time, you're going to get it. First thing you do is you see what the difference is between each two values. How you move from one value to the next with each step. That's what you multiply by. You multiply by that, you get you a column of numbers right here. And you go, oh, that's not 6 isn't 2, 12 isn't 8. And then you ask yourself how to get from 6 to 2. Well, I could subtract 4 and get there. Okay, let's see if that works for everybody. 12 minus 4, yeah, that worked. 18 minus 4, yep. 24 minus 4, yep. 30 minus 4, yep. There's your rule. Okay, let's do another one. Example 4. It'll get better, I promise. It says find a general term for the set. Okay, use the variable in where n is the set 1, 2, 3, 4, and then I have my ellipsis. Okay? And they give me, I need a rule for 7, 15, 23, 31, 39, and so forth. Okay? So, all they did on this one in the beginning is tell you what to use for n. 1, 2, 3, 4, 5. Last time in example 3, they weren't very nice. They didn't tell us what to use for n. They just thought we should know. Okay? But all your homework, it does tell you what to use for n, and it is 1, 2, 3, 4. Okay? So we start off with, here's my n. And it does tell me what to use. It says 1, 2, 3, 4 for n, where n is the set 1, 2, 3, 4. I'm actually going to go ahead and put my next value of 5 there because I have 5 values that they listed. Okay? And this, of course, is my final that I'm going to list beside it. I need to get a 7, a 15, a 23, a 31, and a 39. Okay? Now you're going to tell me how I move from 7 to 15, 15 to 23, 23 to 31, and 31 to 39. We're going to see if it's all the same. It needs to be the same. 7 to 15, you were right, plus 8. How about 15 to 23? Is it 8? Yep. How about 23 to 31? Yep. And 31 to 39? Yes. Okay, so if you need to use your fingers, you can use your fingers. I don't care. Go 31, 2, 3, 4, 5, 6, 7, 8, 9. That's 8. Those you can see good. Sometimes y'all can't see the crossover, the 15 to the 23. Sometimes it's hard for me to see. I'm like, oh, there's 5, there's 3 more. That makes 8. Like I see it in my head. Okay? All right, so we start our big table now. We go in 1, 2, 3, 4, 5. And then what's going to be the next column? 8 in. Good. We're going to do an 8 in. We're going to have a blank column. And then I'm going to have my final. And I need my final to be 7, 15, 23, 31, and 39. Okay, let's find my 8 in. That's going to give me 8, 16, 24, yep, and 40. Does everybody know where we got that column from? We said 8 times the 1 gave me 8. 8 times the 2 gave me 16. 8 times the 3 gave me 24. 8 times the 4, 8 times the 4 was 32, and 8 times the 5 was 40. I didn't write real straight. Okay, well, I was supposed to get 7, 15, 23, 31, and 39. I did not. What should I do to that 8 to get to 7?
-1.
Oh, -1. Let's see what happens. That worked. Okay, so let's see. 16 minus 1. That works. 24 minus 1. Yep. 32 minus 1. Yep. And 40 minus 1. Yeah. Okay. So this was really 8n minus 1, right? Okay. So my general term is 8n minus 1. That's your answer. Okay, that's example 4. Example 5. We have find a general term for the set. We'll write the directions one more time. I'll write them one more time. And then on example 6 and 7, I'm going to say same directions as example 5. Okay. Example 5 says find a general term for the set. Use the variable n where n is in the set one, 2, 3, 4. And we have the set 5, 12, 19, 26, and 33. Okay? Start the process just like we did before. We list n, which is 1, 2, 3, 4, 5. Okay, then I list what my final set is. 5, 12, 19, 26, 33. I find my steps now. From one final to the next, you're looking for the step. 5 to 12 is 7. 12 to 19 is 7. 19 to 26 is 7. And 26 to 33 is 7. Okay? They're all the same. They're all 7. And those strange looking 7s there. Okay, so I've got my n. And then I know that 7 is what I'm multiplying n by. So I do 7n. 1, 2, 3, 4, 5. Okay, I'm going to leave a blank because I might need it. And then I've got my final over here, what it's supposed to be. I go ahead and fill in my final because 1, I know it. And 2, that gives me, it lets me check very easily if that's what I'm getting. Because you will have some problems where all you have to do is multiply by something. You don't have to add or subtract anything. Okay? We just haven't gotten to one yet. Okay, so I'm going to multiply all of n times 7. So it's going to give me 7. Then 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. 7 times 5 is 35. Okay. Well, did I get my final? Nope. Okay. So how do you think I'm getting from 7 to 5? Minus 2. So let's try minus 2. That does give me 5. So now I got to do minus 2 on everybody else. 14 minus 2. Yep, that checks out to 12. 21 minus 2 should be 19. Yep, it is. 28 minus 2 gives 26. That's what I need. And 35 minus 2 gives 33. That's also what I need. So my rule is 7n minus 2. Like I said, you did these during algebra during finding a sequence. Rule for a sequence. And a sequence is simply a list of numbers in a set. Okay. It probably seemed a whole lot more complicated back then, but it wasn't really. Seems more complicated back then because they just throw it in there. Okay, same directions as 5. Here's example 5. And this time I have 80, 160, 240, 320, and 400. Okay? I need my general rule, general term. Okay? So I'm going to start off with n because it said the directions were the same. So that means that set with n in it is the same. 1, 2, 3, 4, 5. My final set needs to be an 80, 160, 240, 320, 400. What are we stepping by? 80s. 80 to 160, that's 80 units. 160 to 240, that's 80 units. 240 to 320, that's 80 units. And 320 to 400 is 80. Okay? You found your number that you multiply m by. That is 80n. Okay? I'm going to leave my blank. And then I've got my final. So I've got 80, 160, 240, 320, 400, 2, 3, 4, 5. Okay, 80 times 1 is 80. 80 times 2 is 160. 80 times 3, 240. Times 4, 320. Times 5 is 400. Okay? Did I get my final?
Yeah.
Yep, I got my final that time. So it's just 80n. Your answer is just 80n. You don't have to worry about adding or subtracting anything from it. They all need to be like that. Next one is not, but it's the last one. We're going to say same directions. Okay, example 7, same directions. I will add on there n equals 1, 2, 3, 4. Just so there's no confusion there. And then we want to obtain the set -12, -22, -32, -42, -52. ... Okay. I've got my n, who is 1, 2, 3, 4, 5. And then I have my final, who is -12, -22, -32, -42, -52. Okay? Now, how did I get from -12 on the number line to -22 on the number line? negative 10. I subtracted 10, right? I went left 10. Okay? Because here's what it looks like, guys. You don't have to write this. So if this is negative 12, negative 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, negative 22, right? So I went left 10. Since I went left 10, I'm subtracting. I minus 10. Okay? How about from negative 22 to negative 32? Yeah, that's negative 10 also. 32 to negative 42 is negative 10, and negative 42 to negative 52 is negative 10. Okay? So now for the big table. I've got 1, 2, 3, 4, 5. You're telling me this is going to be negative 10n. I'm going to erase this number line. Okay. Then I'm probably going to need a blank here. And then I've got my final. And over here in my final, I need negative 12, negative 22, negative 32, negative 42, negative 52. Okay? Well, let's see what we get when we multiply times negative 10. So 1 times negative 10 is just negative 10. Negative 20, negative 30, negative 40, negative 50. Well, I didn't get the final, did I? What do I need to do to negative 10?
Minus 2.
Good, minus 2. Negative 10 minus 2 is negative 12. All right, let's try minus 2 on all of them. Negative 20 minus 2, yep. That makes negative 22. Negative 30 minus 2, yep. That makes negative 32. Negative 40 minus 2, yep. That makes negative 42. And negative 50 minus 2, yep. That makes negative 52. Okay? So that was really negative 10n minus 2. That's what we did in that column. So my answer is negative 10n minus 2. Okay? Are we good? Oh, I should have boxed him. And that is the last example on